step further. And instead of having the sockets, let's use the simple queuing system. We spent a lot of time trying to decide if we could actually do away with servers altogether and have the state of the storage held in the message queues. Okay, when you first connect, you'd have to be brought up to date, but from then on, you don't need a server. It just could come in. The client writes down here. Let's say we have a global write queue everyone can write to after authentication, and then that gets fanned out to the individual clients. Colin and I were chatting about this and trying to get I was using Colin as the janitor. You know, if you don't know you can't understand something, you grab the janitor and explain it to him. By the time you finish, you will understand. And he turned around, he wasn't the janitor, I was. He turned around and pointed out to me limitation of the queuing system after we've read the doc several times. SQS will not allow you to deliver to multiple people reliably. What it guarantees is that it will deliver to one person. So you can have 10 readers and it will guarantee to deliver the message to one. This is really a handy feature, but not if we try and use it this way. Leave that to one side. We'd also still need an archive server to also read off the end of the queue and whack things in the database so new clients can be brought up to date. So that wasn't going to work. So we said, okay, what if we really did have a server there, a Mockingbird server as such? The data's stored in there, and we could have a queue. Every client would write to the same queue when they updated their local data. We'll go into the queue, the Mockingbird server will get that, we'll look at the political rules, and then there will be an individual queue for each client will be created. And queues are very quick to create. You can nail them up, put them down as often as you want. So the Mockingbird server will receive the write from the user, and then it'll punch it back into SQS to each of the individual queues where there are other clients listening, and Amazon can worry about getting it out to them reliably. Now this is really good because it would also mean a client on startup, it can go straight to SDB to get its initial values. It doesn't even have to go through the server. Potentially this is very good, but because this is now stateless, we can actually do another thing. We can have multiple copies of those things. And so the Starga server, or the Mockingbird server, is actually the collection of individual instances. So we call them minions. And this actually could potentially, we haven't tried it, but it could potentially scale very well because these things can be run up and down automatically by the Amazon cloud sizing facilities. And each minion is just going to get a message, and Amazon will guarantee that SQS will deliver to one reader. So if there's 1,000 of them, one will get it, one will service it, one will push it back in the queue to go out to the others. And the minions could actually talk to each other through sockets locally within the Amazon environment. So they could share the load of pushing things back into the queue. So this could work really well, we hope. Alrighty, so what do we got? Shared persistent storage across multiple clients. We use the cloud compute, so the benefits of Tequila One. We use the cloud computing environment to achieve scalability. What are we looking to do longer term? An environment where where domain specialists build applications, the components of which may or may not be on the local machine, they may or may not be on the local network. I haven't got the slide for it, but imagine if Mockingbird is a backplane where we can connect these components. Do you want to have to go out to the cloud? Well, you don't, because, and there's details in the paper, there are implementations of the Amazon Web Services API available as open source to run on your own network. So you can get a thing called Eucalyptus. And we would call that a local cloud. What do we call it? Local area cloud. Thank you, Mike. So you could actually start with a star kit that just has the traditional Tequila One server, or implement your own cloud within your organisation, or go to Amazon, or do all three at once. So you can reap the benefits of using somebody else's big system infrastructure whilst you've got your own little cloud on the side, making sure you've got a copy in case the big company gets out of that business. Okay, any questions? Donald?
Do you have anything for managing the location of storage of the data? So, in case
do I have a solution for you? Amazon, one of those things was CloudFront. That's what Steve was showing you. CloudFront is a facility that automatically moves data to near where the consumers are. behind the scenes. You pay a small fee.
It's just that sometimes there's also policies that you have to implement respecting locations of data and stuff like that. For example, some data has to be held in particular countries.
The Amazon Cloud stuff that we would...
They do relatively well with that.
Yes,
Amazon are one of the better providers.
They don't actually have a cloud front in my country, so I'm the person who tests performance over slow links and all of our stuff. By the way, with the NatLab, we store all those images and sections in S3. Did we turn on CloudFront at all?
Yes, we did.
And it made no difference to me because instead of coming from the US, my stuff came from Hong Kong. But I would imagine that people in Europe, now the CloudFront's available in Europe, if they were accessing a NatLab, it would make a big difference. Any other questions? Oh, sorry, Mr. Redler. Mr. Redler, SCSE, Self-Certified Systems Engineer.
As you explained, the cloud being a device for renting computational horsepower, how does sharing the data provide a cost-effective mechanism as opposed to doing it through a local server service? And really, you're not using the horsepower, you're using it as just a transit mechanism.
Steve, you want to talk on that because you did it with the NatLab?
Well, what the promise of cloud computing is to provide not just hardware power, but persistence and scalability and reliability. What we're looking to do. The chief advantage of the simple storage service is the fact that it's up 99.9% of the time, not necessarily, and it scales really well. So that's the sort of thing we're looking for, which has been a problem for example, key servers. If you read about the disadvantages of key servers, it's a single point of failure. If your key server goes down, nobody can send authenticated messages, and that's been a historical problem. In theory, the same problem exists with Amazon S3, but you're relying on a company like Amazon to deal with that reliability and persistence and uptime issue invisibly to you. You just get to rely on it. So there's more issues than just renting hardware power. There are things that derive from that, like reliability and availability. That's what we're looking for in terms of, it's been the Achilles heel of a lot of client server systems, like chat applications. You have a single server, and up to a point it works okay, and the server gets overloaded because you can't distribute to clients fast enough. And there have been things like BitTorrent, which have tried to get around that by doing peer-to-peer distributions of information. There are disadvantages to that. So what we're trying to look into is a new paradigm where we use the ubiquity of the cloud to overcome those historical problems. One other that answer.
It gets me a little closer.
One other comment on that, Steve, is when we flipped the NatLab onto S3, we did it in two phases. We had the whole thing on Linux. We had the whole of the NatLab on Linux. We flipped the storage onto S3. It went like from a, Linux aren't slow, went from a networked application to feeling like a local application. Instantaneous response. I wouldn't have believed it if I hadn't seen it. And I didn't see it for the first month because I wasn't in the US. But yeah, in fact, Steve and I were giggling like schoolgirls, so. All right, Donald was...
Another point that's actually very strongly in favour of using the cloud services is that it's an awful lot easier to handle all the payment and accounting side of things. And when you're doing on the business side of things, that makes an awful lot of sense, even if you don't get any performance boost from it.
Actually,
the fact that you can actually tie down precisely what you're paying for it and pass that on to the customer fairly, that's actually very useful.
That introduces a limitation in the Amazon system that Steve alluded to with the user accounts. What we're doing, it's in the paper again, is we're multiplexing multiple users of the application onto a single Amazon user. So sometimes with cloud computing, it is harder to nail down the payments if you require everybody to have their own.
It also depends on what model you pick for how you do the thing.
Yeah.
For what we're doing, we're finding it's actually making our payment side of things much easier than running it on our own hardware.
And they handle micropayments if you want to do that. Another one before Scott sends you all out to drink coffee or whatever. Okay, thank you very much for your
Oh,
attention.
sorry. Oh, that's an announcement. Oh, everyone.
We've reached break time. The flash drives are now ready. So head out, talk to Carol Lynn, check off your name on the list that you've got in your flash drive. And they are now all loaded.
So how are we going to move class? I know you're checking for the continuation line thing for a while. The small thing that has to do with the base. You know that?
Yeah, where's that big wheel since we'll have to go around? Watch out, you're being shot.
Okay.
Matt,
Running too fast.
I thought on the chat, I thought this vicious rumor about you.
So,
Just so you know.
Why are there three things I
Don't worry about that.
yeah, okay.
So you probably wouldn't even ever see it. I always test debug build. Why not?
Yeah, I usually have only,
Because you can get
I usually have only regular builds. We have some customers in enterprise, they get debug builds, so they could be able to see it. So it's a good thing if I download it and debug it.
I mean, I'm going to try to further analyze how it's busy. I think I understand. Because if you just look at it, you don't think there's a leak because you're like, everything's being theoretically finalized, but I think it has to do with the order that things are getting finalized.
I see.
Because if you crash the PSP before finalized certain commands to run,
Our final talk of the afternoon is Joe Mustache, who's going to talk about Eagle.
Yes, thank you. So last year I gave a talk on Eagle as well. I kind of introduced the broad different features of it and discussed the rationale why it was created. So I'm not really going to revisit that too much this year because everybody either knows or can see the paper.
Everybody uses Eagle now.
What?
Everybody uses Eagle.
No, I don't think so. I don't know. So what is Eagle? It's a bird.
Yeah.
No, it's an open source implementation of Tickle. I'm just going to gloss over this because it pretty much was covered last year, but it's in the slides.
Not everybody was here last year.
So this, right, but it's available for download also. So Eagle, and I discussed this briefly last year, also has the ability to dynamically load Tickle like an embedded application would. But why would I want to do that? Since Eagle is an implementation of Tickle, why would you ever want to load Tickle as well? I suspect some people might know the answer, or answers. The existing Tickle integration solutions for managed applications are not great. I mean, prior to Eagle. I'm tooting my own horn here. Also, the possibility of using a Tickle-compatible language to control integration of Tickle is interesting. And actually allows certain use cases, which I'll demonstrate in a bit. And that's the last point on that slide. So the Tickle integration features, it supports any build of Tickle TK 8.4 or higher, including base kits and star DLLs. Supports 32 and 64-bit operating systems. It now supports isolated worker threads that each have their own interpreter. It did not support that last year. It supports the creation of exit handlers, supports script cancellation, and it did support that last year. Also, it has a unified stack trace capability that will combine Eagle and Tickle stack traces into a unified error stack. It has support for TIP 335 and 336, which is detecting active interpreters and line number information. That, prior to those tips, it was non-trivial to get that outside of the C application. And also it prevents deleted interpreters from being used. So in an Eagle script, if you want to load Tickle, you do this. This is the simplest example. It detects that Tickle's already loaded because, it's an error if you attempt to load it and it's already been loaded. And then this selects the best version available that it detects on the system. And the algorithms of how it detects the Tickle on the system and also the heuristics for what the best Tickle is described in detail in the paper. Here's an example of specifying some version requirements. In this case, we're saying we want at least 8.4 and no higher than 8.5. Currently, there's no distinction between stable versus latest, like was added to the package command at some point. And then also, you can also just load a specific Tickle library if you happen to know where it is. Here's some basic script evaluation. So we can create a Tickle interpreter with Tickle create, and then eval a script in it. In this case, this merits some explanation because the Eagle command here actually is what I like to call a bridged command. It's actually implemented in managed code. So it equates to the eval command of Eagle. So basically it allows you to evaluate an Eagle script from Tickle and then get the result back through Tickle and then back through Eagle. So it demonstrates like, reentrancy and scripts calling each other. This shows how you can use TK. This just does it in the main thread. And there's some problems with doing this because basically you have to do this, you have to service the event loop using something like vwait or update. So that prompted me to want to have Tickle worker threads that basically just are totally separate from the main thread and can do their own thing, including run TK or run something that requires the event loop, and not block the main thread from doing something else. And I haven't wrapped it up in a nice API yet. These examples on the slides are, I put them together fairly quickly because I didn't have time to wrap the worker thread API into a simpler command syntax, like as a part of the Tickle command. So now you basically, this is actually calling .NET managed methods. So that's why it looks a little bit more verbose than it probably ought to. Last year, popular question was, does it run on Mono? And I had to answer no, because I hadn't even tried to do that at all. Now it does. 2.4 or higher is recommended. I actually worked with them to report several issues with earlier versions, and there's a couple that are still outstanding. All the major ones have been fixed, however, the crashing bugs. So now I guess we'll do the demonstration. So the first thing I'm going to demonstrate is, actually I suppose I'll just do the sample now. So I wrote a sample application here that demonstrates using the Tickle features of Eagle from a managed application. So what happens is this is actually a win form. This is actually a form. So right now, in order to use Tickle, you actually also have to create an Eagle interpreter because just mostly for the sake of having some context to stick stuff at. That may change in the future. So Tickle is loaded using this method right here, which is described in the paper also. And then right here, I actually create a bridged command. This actually creates a command in the interpreter, which actually the master interpreter. So when you initially load Tickle, this interpreter becomes the master interpreter, and then you can actually use it. I mean, normally I don't use it; I just leave it there. But you can use it, and this actually does take advantage of it. So I am using it. And then I create the command here, and I call it class 6 basically, because that's just a sample class. So what this does is, and so here's an example of the active handling right here. So this prevents the form from being closed if there's a script active. It's a useful feature. And then to evaluate a script, you do tickle wrapper.evaluate script, which takes a tickle API object, the tickle interpreter, and then the text, and then by ref result. So one of the interesting features of this is instead of having to query the result in a separate method call, you basically just get that back in one call. So the tickle integration features automatically manage the interpreter result for you and just hand it back to you. Because otherwise you'd always have, get result after that anyway. Actually, I think I'm starting the wrong thing. Reset the startup function. Okay, so I'm going to start this. This just presents a simple form that basically just allows you to evaluate something. So that's pretty simple. And since everybody seems to love Tetris today, thank you, Jeff. So this demonstrates running Tetris. So whenever I can also create a bunch of interpreters. Every one of these forms gets its own interpreter, so I can have these interpreters doing different stuff. Like I can just have this one sit in an infinite loop, basically. That one's just locked up. It's just sitting in an infinite loop. My Tetris is still running. Separate threads. So now if I cancel this, then Tetris is not running, and this one that was in an infinite loop, actually that's not the right one. One of them that was in an infinite loop, there we go, it's been unwound. So that's good. That's what it's supposed to do. I can go ahead and close that. So let's just look at how you use this from the script level, because that sample is the C# sample that demonstrates how to use the tickle integration features from C#. This demonstrates how to use them from Eagle, which is also how it's shown on the slides. Is basically the tickle ensemble. So one of the interesting use cases that I found as a maintainer to be interesting, and it might not appeal to everybody, is I wanted to be able to easily check for memory leaks when I was loading and unloading a tickle library in an embedding scenario. So this uses the tickle memory debugging features to do that. It basically sets the memory leak file and then creates and deletes an interpreter and unloads the library, and then basically says, yes, we expect there to be 0 bytes of leaks. And then the second one demonstrates, repeatedly doing that to see if the leak is repeatable. So there's 2 different tests I have for this that are very similar. So I mean, it's unique. This merits some attention because I don't think there's any other tools that allow you to test this type of automation of tickle, programmatically controlling the loading and unloading process from a tickle-capable language, basically. So I suppose, how else would you go about doing that? So I'm going to go ahead and run this, actually. So this shows the unit testing framework in Eagle, which last year was incomplete. Actually, I see. In that case, it didn't run those tests because they're marked as isolated. So I guess I'll run that from the demo. So one of the things you can do is you can specify which tests you'd like to run. So as you can see, there are several leaks currently in head. I'm going to be getting to look at those later this afternoon. So yeah, this is nice. This gives you a nice report. It's actually less serious than it seems. We're just leaking a particular hash table. But as you can see, the unit testing framework, if a test passes or if it's skipped, it's in green, and if it fails, it's in red, which is nice color coding. Okay, does anybody have any questions for me so far? We're at the question phase of my... So it's available at eagle.to. The latest builds are up there, which is today's build. I fixed several issues. So please download it or re-download it if you have downloaded it not today. It's also, the latest versions are on the FOB. So any questions? Ron?
What is Eagle and being used for now?
I do not know. I suspect it's being used, but I don't know where.
Are you using it? Or are you using it for? Or are you just
Well, I'm just using it to have tons of fun. Gerald?
Do you have a timeline to bring it from mostly 8.4 to mostly 8.6?
Well, I have stolen various features from 8.5 and 8.6 that were important to me personally, but I mean, I guess it's going to depend on demand from the community in terms of what people want to see, and also if they wish to help me implement them. Several people have asked for namespace support because that's one thing that it does lack, and I am not too excited about adding that because it obviously complicates things a great deal. So, in the original timeline of the project, that there wasn't sufficient time to do something of that complexity in the initial thing, and so now I have to go back and change a bunch of stuff to make that work.
What's the code size compared to C in C# compared to C?
There's actually less. There's a lot less code because the .NET framework provides a lot of high-level abstractions to stuff that you would normally have to do yourself in C. So that in Tickle we do, and such as the channel system, and encodings and stuff like that. All that is handled by the framework, and even regular expressions. So I can borrow a lot of their functionality and just use it, wrap it, and use it verbatim. Other questions? Richard?
Eagle is a complete re-implementation from scratch, or is it borrow code from the C?
I stole the algorithms and rewrote them for managed code. I mean,
Right.
being that it's...
I mean, so you brought up the ANSI C in one window and then kind of typed in the C# in another window?
Yes.
With generous copying and pasting, or did you just start
Well,
with a blank slate?
you can't really copy and paste. As an example, the first thing I implemented was the parser. And the parser in Tickle is elegant and beautiful, but it also does a lot of stuff which is forbidden in C#, such as pointer arithmetic,
Sure.
and pointers in general, which you can do in C# if you use unsafe mode, but I was not allowed to do that, so I had to implement everything in terms of objects and arrays and the managed concepts that are exposed. So yeah, it's a re-implementation.
Okay.
And it supports weird things that Tickle doesn't do. And the one last year that seemed to interest people was interpreter-wide variable tracing. So in Tickle, if you want to trace a variable, you can do that. In Eagle, you can trace all operations on variables in the entire interpreter, which gives you possibilities to do more Eagle things.
So you mostly talk about being in Eagle code, looking backwards, so to speak, into an ordinary Tickle process. True.
It's not a Tickle process. Tickle's loaded in the same
It's
process.
in your process, but it's the Tickle interpreter is vanilla. It's
Right.
Whatever version you want. So what I'm wondering is, what advantages or differences? What would you call out are the advantages of things you can get at from inside Eagle in the C# world that you wouldn't be able to do in Tickle?
Managed objects for one thing, right?
Yes.
Such as objects written in C# or that are objects written in VB.NET or what have you, or now F# or any of the other managed languages. And basically, when you have an Eagle command, you get a Tickle command for free. Because if you implement the iCommand interface, that immediately is also eligible to be a Tickle command. And you don't have to know any native code to add commands to Tickle, basically. It removes that requirement. So a C# programmer will be able to easily extend Tickle. Yes.
Would it be a tool that, say, a lazy network admin who's just getting on to, say, Microsoft Server 2000 could take a couple of the management scripts over from?
Yes, exactly. And the other thing is now Eagle integrates with PowerShell, which is a new feature. And so if there's an admin who's using PowerShell who goes, oh golly, I'd like to do something in Eagle or Tickle, it's very simple. No one? Okay. Thank you.
Thanks, Joe.
You're welcome.
Okay, we've got exactly 1 hour for 6 work-in-progress sessions. So it's going to have to go really fast, 10 minutes a person, with a pretty hard deadline. You're going to have to get on, do your thing, get off to the next person to come on. First up is Roy Terry, TCATCon. Well, I'd say whatever you're comfortable doing. I think these are a lot less formal.
Yeah. Well, I'll start talking. It's nice to have everybody here. Wow, it's a intro first. So this is really just brainstorming and it's based on my use of TKCon over the years, which I don't see how you really can do any development without it. Jeff did his free tutorial. He didn't actually mention the sort of most basic feature, which is so helpful, which is no matter how complicated your command lines were on Monday, unless you crashed, they're there on Tuesday. You start back up, you start pushing up arrow or Control P or Control R, it's all still there. But TKCon's pretty basic. And so, you start to think about wanting more. I want right now this mic to hook up. What am I connecting to? Let's see. So, by way of just brainstorming, let me put my glasses by way of just brainstorming, I made up a few impress slides. This is just to sort of record me thinking of things that might be nice to have in an enhanced TKCon. So I'll just throw that on. Am I showing? What do I need to do here? Let me see. I'll get this guy. Let's try this. It's doing nothing, but it's taking a long time to do. I'm not sure why. Actually, I'm slightly pessimistic because the first time I pushed F5 in Impress on this particular computer, I had to power it off. Something in the video driver went into an infinite loop.